Infinity Labs, an open education initiative. Welcome to our video series about solid programming principles. In this series, we'll be exploring the 5 principles of solid design and how to apply them in your own code. In this particular video, we'll be diving deep into the single responsibility principle, which is one of the most fundamental principles of solid design. We'll be discussing what the SRP is, why it's important, and how to apply it in your own code. By the end of this video, you'll have a solid understanding of the single responsibility principle and how it can help you create more maintainable and flexible code. Single responsibility.
The single responsibility principle states that a class should have only one reason to change. In other words, a class should have only one responsibility or job. This means that a class should be focused on doing one thing and doing it well. The single responsibility principle is important because it helps to create more maintainable and flexible code. When a class has only one responsibility, it becomes easier to change it without affecting other parts of the code. This makes it easier to add new features, fix bugs, and refactor code as needed. Let's analyze the benefits of it. By ensuring that each class has a single responsibility, it becomes easier to modify and maintain the code. When a class has only one reason to change, changes to that class are less likely to affect other parts of the codebase. Classes with a single responsibility tend to be more modular and can be reused in other parts of the codebase. This can reduce code duplication and increase overall code reusability. Classes with a single responsibility tend to be more focused, making it easier to write unit tests for that class. This can help identify bugs early on in the development process. Classes with a single responsibility tend to be easier to understand and reason about. This can make the codebase easier to read and maintain for other developers who may need to work on the code in the future. Classes with a single responsibility tend to be more scalable, making it easier to add new functionality to the codebase without breaking existing code. This can make it easier to add new features and improve the overall scalability of the codebase. To apply the single responsibility principle, start by identifying the responsibilities of a class. A good way to do this is to ask yourself what the class does and what it's responsible for. If you find that a class has multiple responsibilities, consider splitting it into smaller, more focused classes. Each of these smaller classes should have a single responsibility and be focused on doing one thing well. You should keep classes small and focused. Avoid putting unrelated functionality into a single class. Use composition to combine smaller, focused classes into larger, more complex functionality. Refactor code as needed to ensure that each class has a single responsibility.
Let's dive into a code example exercise to better understand the single responsibility principle.
Suppose we have a class called user that is responsible for both managing user data and sending email notifications to users. This class has 2 responsibilities and violates the single responsibility principle. Let's take a look at the single responsibility principle in code. As previously discussed, we established a hypothetical scenario that breaks the single responsibility principle. In order to fix this, we can split this class into 2 smaller and more focused ones: User Manager and Email Notifier. The User Manager class is responsible for managing user data, such as creating and updating user accounts, while the Email Notifier class is responsible for sending email notifications to users. By splitting this class into 2 smaller classes, we can ensure that each class has a single responsibility and is focused on doing one thing well. This makes it easier to maintain and update the code in the future. In conclusion, the single responsibility principle is an important principle of solid design that helps to create more maintainable and flexible code. By ensuring that each class has a single responsibility and is focused on doing one thing well, we can make our code easier to understand, update, and maintain. Remember to keep classes small and focused. Avoid putting unrelated functionality into a single class. Use composition to combine smaller, focused classes into larger, more complex functionality. And refactor code as needed to ensure that each class has a single responsibility.